Next speaker will be myself. I'm going to talk to you guys a little bit about the differences between manure and chemical fertilizer. I'm sure there's no surprise that there's a difference there. And just briefly too, in the spirit of going through speaker bios, I know a lot of you, but I don't know all of you out there. And so my name is Nichole Embertson, and I'm a nutrient management specialist at the Whatcom Conservation District. But I also work in other areas of the state as well. So kind of the whole west side, I may kind of dabble around here and there, helping implement different programs related to nutrient management, in particular, technical assistance with research and education on manure application risk management tools and developing kind of those real-time tools and advisories for you guys to use. So that's kind of who I am, if you will. So let's just briefly talk a little bit about chemical versus manure when we talk about fertilizers. And I just put this up first. This is what's called the 4 R's of nutrient management. And some of you have heard me make a joke about this. The only 4 R's is that they all start with right. So it's the right time, right rate, right source, and right placement of whatever you're using. Chemical fertilizer, manure fertilizer, whatever it may be. And this is really important because when we think about when do we have a pollution event, when do we have an issue, it's when one of these things is out of alignment. So you always want to make sure that, and we're going to, go through some of these parts and pieces many times throughout the day, but just to put this up to get your brain kind of thinking about one of these things. And in particular, when we're talking about manure versus chemical, we're kind of more thinking about this part, the right source. What source of fertilizer are you using? And in particular here, when we think about manure versus chemical, I've just put up a couple of the bigger kind of differences of these two things. And the biggest one in particular is what they're composed of. Manure, when we look at just nitrogen, which is mostly what you're concerned about and what you grab, or what you're kind of thinking of first for getting your fertilizer out there, you think about how much nitrogen does my grass or corn or whatever it is need. Some of the other things kind of fall second. But with manure, it's composed of 50% organic nitrogen and about 50% ammonium nitrogen. There's no nitrate in it. And when you're thinking of what does my crop need, it needs nitrate. So manure has to convert to that plant usable nitrogen form in the soil. So you have to apply it. It has to undergo a biological system change in the soil to convert to that plant usable form. Chemical fertilizer in most cases is ready to go. You're putting on ammonium nitrate or something of that sort. There's many, many different types, but you're putting on a specific formula that you need. That's kind of nice. You can have that very customized NP and K ratio that your crop needs at that specific time. Manure, not so much. At best, you're getting your manure test. You're hopefully getting that value back ahead of time. You're doing some calculations. You're figuring out nitrogen. But in most cases, if you're applying a nitrogen, your N and P are probably a little bit out of whack. So that's a challenge with applying manure versus applying a chemical-based fertilizer. One thing though that's really positive with manure is that yes, we think about nitrogen, phosphorus, potassium, NPK, but there's a ton of other really good things in manure. You've got organic matter in there. You've got all of these other macro and micronutrients and minerals that are really good for soil health and soil tilth. It builds that soil health in there. That's a really big positive. Chemical fertilizer does not have that. It doesn't considerably add to soil health and soil tilth. So manure really has an added advantage there. One of the other disadvantages of manure that we have to operate a lot, and you guys are well aware of this, is that yes, manure contains pathogenic bacteria associated with fecal coliforms, unfortunately. So chemical fertilizers do not. That's an obvious one. So we do have that difference. Chemical fertilizer also, you're usually getting it on there, it's getting right in. Manure does have some, you're applying it on the surface. There is some leftover product there. So, but that's all that great organic nitrogen and carbon factor in there, organic matter that's on there. So Manure really does probably win overall when we're looking at crop and soil health. You just have to be a little bit more considerate with it when you're applying it, on when you apply, how you apply, the rates that you apply. Your timing is really important instead of chemical fertilizer. A lot of folks will mix these two things. You might use chemical fertilizer early season when you are worried about runoff issues, but you know you can get a little fertilizer out there, and then your manure comes back into play. Most of you, I'm guessing, apply manure because you have a lot of it and you got to get it out somewhere. So we've got that. So let's put that aside and pretend you're not just trying to get rid of this stuff, but that it's a really valuable product, and we'll operate within that. I might be biased as a nutrient management specialist who went to school for a really long time to put value to manure, but I think it's an awesome product. So I want to hopefully impart some of that to you guys as well. So just a little brief about manure specifically, and let's look at nitrogen and phosphorus again, because these are the things that we care most about and that we are going to spend a lot of our focus and time on. Is that when we look at, and don't worry about it, I don't expect anyone to memorize or see this, really, it's a bit small, but this is essentially the nitrogen cycle, just to show it's all over the place. Phosphorus is pretty easy. You apply manure to the surface, there's phosphorus in there, and it doesn't really leach down. It's mostly kind of lost by sediment. So you lose it when you get rain on that surface. That manure hasn't incorporated into the soil, it hasn't been taken up by plants, so it's going to be able to be lost through runoff if that occurs on your field. That's pretty much how we lose phosphorus. Phosphorus also builds up. It doesn't volatilize, it doesn't leach very much, it just kind of stays there, so it builds and builds and builds. And that's why it's become more of an issue over time, is that you may see your phosphorus levels are going up and up on your soil test, but you may also ask, why is this a problem? Is this a problem? We're going to talk about that in the next talk. So also an important thing to consider, but nitrogen is a challenging one. So nitrogen is easily lost by many different pathways. You can also lose it from runoff. You get rain and it goes, but you can also lose it from volatilization to the air. You can lose it from leaching, which is a very common pathway for loss. And of course you have your plant uptake, which is hopefully what you want to get all your nitrogen to do. You want to apply just enough so your plants need it. But again, with manure, we have to consider soil temperature, microbes, soil moisture, soil pH. What is that manure composition that you're putting on? A lot of things go into the availability of that manure nitrogen and the conversion rate to that plant usable form. For instance, when we think about soil temperature in particular, the soil has to be approximately greater than 40 degrees Celsius for the soil bacteria and microbes to convert it to nitrate. That matters for a couple different reasons. So you'll get a little bit of conversion ahead of that, but that's kind of like, we'll just use that as our marker for change. And this can kind of work for you in two different ways. If you apply manure under that temperature, it can kind of be locked up in the soil there. You're not getting a lot of nitrate conversion and loss to leaching. It's probably going to hold it. As the soil warms, you're going to have that conversion rate. You're also going to have, let's say, grass growth. At the same time, you're going to have a nice kind of matchup there. If you apply, your manure when it's really warm, that conversion rate is going to be a lot faster and it's going to be more readily available. So that's kind of a challenging thing to know and to kind of match up a little bit. I've got kind of an example here. There's a lot on this graph, but the things that you want to know. So this is a grass growth chart here, and essentially we're looking at total percentage growth throughout the year. This is January to December at the end. And we can see that, yes, we get increasing growth January through about May, June, and then it just starts slowly decreasing. If you irrigate, you're going to help your kind of summer growth. This, again, very soil type dependent. Let's say this is a bit of a more well-drained soil that may need some irrigation for that grass crop. And then what I've got here is these are our hypothetical grass cuttings. Let's say we get 5 cuttings off of this field. And you're probably going to apply manure about the same time. It's convenient, right? You cut your grass, you get your manure out there, and hopefully it's all converted and used up at the same rate of your grass growth, which is pretty darn close. The two hard manure applications are the first one and the last one. And we're going to talk again, we're going to touch on this a few times throughout the day, but this is where we're kind of concerned about when you apply this January or February. Can you apply January? Yeah, you might be able to on certain soil types. So we're seeing a lot of data now with some of our trials that we're doing where it is appropriate to start applying outside of those set dates. And I'm giving you a teaser for this because I'm going to talk about it more today. I want you to stay throughout the day. So there are these things. And then at the end of the year, applying in September, October, is that useful? Not on a good chunk of our soil types. In fact, you apply at that time, with this grass growth decreasing, you still have all that conversion because the soil's warm and manure is converting. Your grass is only taking up a fraction of that. So all of the stuff that's left over, that's this fall nitrate test, is a lot of that's lost. So the fall nitrate test, we'll go over that again too. It's not really indicative of that. It's just kind of a tool for you to use to be able to gauge some of these properties. But applying in October may be just complete waste management. It's not nutrient management on certain soil types like your sandy-based soils. Your heavy soils, it may actually help. So we've got a few of those kind of properties to really think about here with when you apply manure. Chemical fertilizer, you apply it, it's ready. You apply it, it's ready. You apply it, it's ready. Manure just takes a little bit more thought, a little bit more science to it. So, and I know you guys are all dairy producers, and it's probably one of the hardest of all livestock productions on keeping up with things and the complexity of it. So I know you can handle manure complexity. Not too bad. So again, some of the challenges of manure are this nutrient availability. When is it going to be available based on those conversion rates? And the concentration is hard. Unfortunately, manure is always the opposite. It's in the beginning of the season, you had a lot of rain and it's really dilute. So in 1,000 gallons, your concentration is very low. Where if we look at, let's say, September, when we haven't had a lot of rain for a while and it's really just manure, that 1,000 gallons, now your manure, your concentration of nutrients is much greater. So the volume you apply throughout the year has to account for that. That's why we ask you guys to take manure tests, so you know that. Where, let's say in February, you've got 8 parts, or 8 pounds per 1,000 gallons of nitrogen, whereas in August it may be 20. You can't apply the same, 8,000 gallons or 10,000 gallons, etc., to your grass on both of those. So you need to start balancing that. We would prefer that you have more nutrient concentration early season and less late season when we can match that grass growth. But unfortunately, it just doesn't work very well that way because we can't get the volumes out early season. So this is where things like good clean water management comes into play, keeping out as much of that water as possible, lagoon covers, or some of these new technologies, which Chris will talk about later. So there are a lot of those. So we do have to work within that. It's a little bit of a challenge as well. And then application timing and hauling, selecting the right field can be challenging. Getting it out to the right field at your convenience is very challenging. Do you got to haul to that one? Oh, this one's more convenient. I only have a few hours. I'll use this. I got the big gun. I got to call the custom guy. I want him to come Tuesday, but he can't come Friday. All of those things are also a big challenge when it comes to manure application as well. But there are ways to work within all these things that we'll talk about as we go through the day. So some challenges with those pieces.